All right, guys, welcome to our zero point 0.4 evaluating absolute values notes. So today we're going to be talking about absolute values and pretty much how that works with GEMDAS. Now, for the first page, it's actually a fantastic, just kind of like exploratory opportunity where I just want to encourage you guys to check it out. But for kind of like what we're focusing on, we're going to go ahead and continue on to our Mount Everest example. But again, maybe if you finish the notes early, go back to these and then just try and use them for a real world application. Okay. Now, on page 2, we see that the sea level of Mount Everest has an altitude sea level rather, has an altitude of 0. So if you imagine like the ocean, that has a sea level of 0. Mount Everest, on the other hand, if you know this one off the top of your head, has an altitude of 29,032 feet at the time of this recording. Now, in previous years, I've kind of seen that number differ, not by much, but yeah, in 2024, it's now 29,032. Like I think last year or the year before, it was like 29,027 feet. So, but yeah, Mount Everest is 29,032 feet high. Now, if you think about this as we talk about absolute values, what would have to be something like a negative altitude? Well, if sea level represents 0 and Mount Everest is 29,000, over 29,000 feet, then a negative altitude would be something like, underwater. So under sea level. And so a prime example of that would be something like the Mariana Trench or, just things that where submarines would end up or, fish that are deep down in the depths of the oceans and whales can go into. But at the end of the day, when we're talking about things of altitude, yes, you have different levels of altitude, sea level being 0 and things above that sea level, like Mount Everest being above that. There are certainly things under it, namely the whales under the ocean. However, what's important to note here is that there is some distance away from usually we call sea level as kind of like the baseline. Um, so that there's some distance that you can at least measure, above sea level or below sea level. And so that's one area where absolute values can be kind of handy. Now, today we're just kind of looking at expressions with them. So, and with the GEMDAS, how that kind of fits in. So as we look at example 3, we have the absolute value of 5 plus 13. Absolute values, what I want you guys to start thinking of is that they operate and behave super similarly to a grouping. Okay. And so as a result, inside this grouping, we've got the 5 plus 13. That is the absolute value of 18. And then the absolute value of 18 just comes out to be positive 18. So we've heard that absolute values tend to make things just positive. I'm apprehensive just to say that's always the case, but today for expressions, that's going to be more of the case. Okay. It also depends on other certain circumstances around your absolute value. So example 4, we've got the absolute value of 5 minus 13 or 5 plus negative 13. Again, just reiterating the point of anytime you see a subtraction symbol, it's really a negative number that follows it. So 5 plus negative 13 comes out to be negative 8 in the absolute value. And the absolute value of negative 8 comes out to be just positive 8 in the end. Because again, absolute values is more the distance away from your 0 level. For example, 5, there's a couple different approaches that you can attack it. However, according to GEMDAS, let's just focus on the grouping part first. So here we have the 3 plus the 8 kind of seen as the innermost grouping. So you end up then with 2 times the parentheses 11 there. And now inside of this grouping, in the absolute values, you have 2 times 11 is 22 in the absolute values, and the absolute value of 22 is just still 22. Next up, for example, 6. Again, you really want to attack this from the innermost and then work your way out. So in all of math, with the innermost grouping, we end up with the absolute value of -7 times, here this would give us 6. And then inside that absolute value, you are doing operations. So in this case, a multiplication. So you have -42 there. And then the absolute value of -42 is just regular 42. So positive 42. Now, as we move on to 7, again, you really have to follow GEMDAS. So here we have 16 divided by, this is a grouping going on first. Because again, you have to treat absolute values much like a grouping. The multiplication, division, exponents, that comes afterwards. So here you end up with 16 divided by the absolute value of -4 is just normal 4. Now you end up with 16 divided by 4, which would just yield us 4, normal 4. Moving on to example 8. Again, anytime you see an absolute value, just kind of think, hey, there's a grouping going on there inside that expression. So 1 plus -4 is going to be -3 inside that absolute value times -2 on the outside. Now, it's commonly thought that you might just want to like do -3 times -2. No, according to GEMDAS, absolute value is seen as kind of that grouping component. So as a result, you end up then with the absolute value of -3 is normal +3 times -2. And then 3 times -2 is going to give us that -6 correct answer in the end. And so this is where a lot of, not a lot, but several, enough to mention, where students can accidentally do an operation before they're supposed to. So like if, for example, you thought, hey, I end up with, absolute value of 6 because maybe you accidentally multiplied these two guys together, that would be wrong. Okay, so there is a certain order. Just think absolute values, they're treated as a grouping when we're talking about expressions. Now, from our previous lessons, we've talked about where, okay, we've got a fraction. This entire numerator is seen as one set together. Likewise, on the entire bottom is one set together. Now, we have this negative in front, right? So what are you supposed to do with that in typical practice? Generally, I just always advise my students, if you see a negative in front like that, just throw it to the entire numerator. Okay, it's just going to help with your own consistency, especially when you eventually get to things like slope, and other high school topics are going to, especially like rational functions. So just generally, if you see a negative sticking out there in the front like that, just usually attach it to the top. Okay. It can go technically on top or bottom. It really doesn't matter, but generally just to make things life easier and consistent, just throw it up top. So you end up with -12 on the numerator all over the absolute value of -1 plus 1. So I didn't really do any math in that red step. I kind of just said, okay, I'm taking my negative, throwing it on top. Now, in the numerator, I have -12. So as a result, I just end up with -12 on top. On the bottom, I have the absolute value of this -1. And so that comes out to be regular +1 plus 1 in the denominator. In which case I end up then with -12 on top still, over 1 plus 1 on the denominator comes out to be 2 on the bottom. And again, we did that because this guy was seen as that grouping. That's where we got that 1. 1 plus 1 is 2 on the bottom. And then we divide. So you end up then with -12 divided by 2 is -6. in the end. All right, now things are getting a little spicier where we have multiple negatives going on and absolute values. But again, when it comes to GEMDAS with expressions, you always work your inner way most and then work outward. So this is seen as the innermost. So that absolute value inside of this grouping is the innermost. And so as a result, we end up with 3 minus 3 in that absolute value, which is 0. And all I'm going to do is just rewrite the rest and just kind of tackle it one step at a time. Now, the absolute value of 0 is just 0. And now inside that grouping, I have 0 minus -4. Well, anytime we're subtracting by a negative, we're really adding a positive there. So 0 plus 4 comes out to be 4 in that grouping. And then finally, we end up with 4 times 5, just normal 4 times 5, which is 20 in the end. Now, for some of my students who try and do like multiple steps in one, generally what happens is they mess up with some kind of negative issue. So these are really the steps that you should be showing, all of those. And especially in high school, they're not going to just stop with like 4 steps like you see right here. They're going to do 10, 12 steps, especially in more of your pre-cal classes. All right. Example 11. Now we're getting to evaluating with these items. Previously, we're kind of just said, hey, here are your numbers, go at it. But our kind of more end game with this is saying, hey, here are our variables, and this is what Q and R are. Well, just like how we were learning with GEMDAS, you first dump them in. No math whatsoever. You just say, hey, my reader, my math teacher, myself even, to reference as later for notes and studying for tests and quizzes. I'm not doing any math. I'm literally just dumping these numbers in exactly where they belong. Now, step 2 is where you can start doing some of those GEMDAS operations. So you end up with 3 minus, again, this is seen as a grouping, so he's going to come first. The absolute value of -1 is normal 1. And then we end up with 3 minus 1, which is 2 in the end for that expression. All right. So for example, 12, we end up with the absolute value of J minus H. We have H and J. We're going to go ahead and throw those items in first. So we end up with the absolute value of J, which is 6. Again, always throw parentheses around when you're evaluating and dumping those numbers in first. Minus parentheses 5. Now, again, seeing that the absolute value is kind of like one big grouping going on, the absolute value of 6 minus 5, we just end up with 1. And then the absolute value of 1 is 1. So you should just get 1 in the end. For example, 12. Next up, what I want for you guys to do is pause the video right now and sincerely try 13 through 16. Okay, just pause it, give it a fair shake, going through the exact same motions. First step, plugging the numbers in, and then following GEMDAS like you guys have been seeing with those absolute values now involved. So go ahead and pause the video and try those. All right, depending on your accuracy, you guys will see the answers, but skip as you need to, only if you got it correct and you tried it on your own. Okay? Because you will be getting those work points. So for 13, if you need to see that one, maybe you didn't get the same response. Let's take a look. We end up with the absolute value of P, so that would be -2, plus Q is -3, divided by 5. With that grouping, you end up with -2 plus -3. We end up then with -5. Absolute value of -5 is regular 5. And then 5 divided by 5 is 1. So you should have gotten 1 there. As we look at 14, we're going to dump our numbers in parentheses. So 5 times h is -1. I want to highlight right here. Notice the first parenthesis was from the expression. This second parenthesis was from me inserting that h value in there. Okay, they're their own parentheses that will matter as you progress in high school math. So then we end up with minus absolute value of h is -1. And then close parentheses. So again, first step, just dumping the values in. So we end up then with 5 times. This is seen as the most innermost. So we end up then with -1 minus absolute value of -1 is regular +1. And then we have 5 times -1 plus this -1 is -2. You could also look at it like -1 minus 1 if that's easier for you to see visually because there's just a lot of parentheses happening right now. So you still get -2 though. And then 5 times -2 is that -10. So you should end up with a result of -10 there. For number 15, again, first step always with evaluating. Just dump the numbers in, no math. H here is 6 plus absolute value of j is -4. And then absolute value, you've got a couple different ones, but we go from grouping from left to right, like innermost always, but then since like this has the same amount as this one, left to right. So absolute value of 2 is just 2. And you could even like technically do this step in the blue, kind of doing it one step at a time. But for this problem, if you had gone from 2 plus 6 plus absolute value of -4 is regular 4, I would give that to you as your teacher. I would give that to you. And then adding and subtracting from left to right, 2 plus 6 plus 4. This is going to be 8 plus 4, so 12 in the end. You should have 12. Number 16. As always, dump in the numbers first, no math. So absolute value of -3 minus our y value here is -6. Super important to note, this negative or subtraction symbol is that one, and y just happens to be a negative number. They're their own negatives. That's what trips people up. So just be careful of those negatives. Plus, our y on the outside of that absolute value is -6 minus 1. So that's why that first step is so important. So you're getting all the correct signs in where they belong as you just dump the numbers in without any real math going on. Now, the absolute value, this is seen as our grouping. And so within that grouping, we have our -3. Inside of that grouping, you're really doing like, okay, do we have any grouping parts in that grouping, or do we have exponents and then multiply, divide? Remember from class, we talked about this is secretly a multiply. So -1 times -6 going on there. So negative times negative is a positive 6. You could also recognize it from class where we said, hey, if you're subtracting by a negative, you're really adding a positive. So you end up with this plus sign in between. Okay. Just different ways to attack it with the same correct conclusion. So plus -6 minus 1. I like to give students several options as to what pathway they're thinking makes the most sense for them. As long as it's still correct, though. Absolute value of -3 plus 6. Again, that's still a grouping that you're doing. So then that ends up to becoming absolute value of 3 plus -6 minus 1. Absolute value, that is really still seen as our grouping going on. So you have to really continue to do that first. Absolute value of 3 is 3 plus -6 minus 1. And now we're essentially just adding and subtracting from left to right. So 3 plus -6 would be -3 minus 1, or -3 plus -1, for a grand total of -4 in the end. You should have gotten that. So again, as you paused and you tried those, you should have these answers. If you didn't, you can kind of go more specifically into the ones that you need. All right. What I want for you guys to do now is go ahead and try 17 through 20 first on your own, because really the goal here is for you to be able to do it on your own. But if you need to, then afterwards, check your results. Okay, so I'm going to give you a few minutes to go ahead and pause the video and try these next 4 questions. All right, now that you've had a chance to try these, we're going to go ahead and look at 17. So dumping these values in, we end up with 3 minus p is -4 plus absolute value of m, 4 minus another m, 4. Again, no math in that first step, just dumping them in parentheses. Now, this is seen as the innermost grouping because it's that absolute value within this outside parentheses. So everything else, we're going to go ahead and drop down. Not going to get rid of parentheses. Literally just drop it down. Inside of that absolute value, 4 plus -4 is 0. And then right now, it can be a little tricky, and this is why order matters. This is still seen as the innermost grouping. All right. So you end up with -4 plus 0 there. Because otherwise, if you accidentally start combining things that shouldn't be yet combined and then absolute valuing later, you'll just get a different result in the end. Now that we've done the absolute value, inside of this grouping, this kind of like outer grouping compared with the original, -4 plus 0 is -4. Again, we just keep dropping down everything else. Work your way from the innermost to the outermost. And now we end up then with 3 minus -4. Well, if we're subtracting by a negative, we're really adding a positive. And so you should end up then with 7 in the end. Okay, so if you need to go back and check that one, rewatch parts of the video, feel free to do so on 17. For number 18, again, first step, always just dump the numbers in. So we end up with -6 in parentheses. M is a 1 plus absolute value of -1. minus our n value is -6. Now, when it comes to GEMDAS, innermost grouping would be this guy. And really, the innermost would be this guy with that absolute value part. So everything else, as a result, we're going to go ahead and just drop down. Now, absolute value of -1 is normal 1. Notice I'm just copying everything else I did. And now this is our other grouping, a little bit further out, but we're still kind of focused on that grouping with GEMDAS. So 1 plus 1 is 2. And as a result, now we end up with a bunch of just different multiplication that's really occurring here. So here is a multiplication, also -1 secretly behind the scenes times -6. And so thinking about from left to right, you end up with -6 times 2 is -12. And then -12 times -1 times -6 is +6. Negative times negative is positive. And so in the end, you should end up then with -6. So there are 17 and 18 if you need to kind of go back, pause the video, rewatch certain parts. Now let's go ahead and take a look at 19 and 20. Again, first steps, just dumping the numbers in. So we have absolute value of A, which is 3 in a parentheses, B, which is 6 in a parentheses, its own parentheses, minus absolute value of B, which is 6, plus just a 6 on the outside in a parentheses because we're placing that number inside there instead of the variable. Now, with our innermost grouping, here we see an operation occurring, so a multiplication inside of that grouping of the absolute values. That's going to take precedent over this one, especially also because we work from left to right. Okay, so when we do that, we end up with 18 in the absolute value. And then absolute value of 18 is just 18. And then now we have this next grouping that we're kind of looking at, this absolute value right here. So 18 minus absolute value of 6 is just still 6. And then 18 minus 6 plus 6, really we're kind of just adding and subtracting from left to right at this point. So that would be 12 plus 6. So eventually back to 18 in the end. So for number 19, you should have gotten 18. All right, next up, number 20. Again, first step, as always, dump those numbers in, no math. So we end up with -2 minus. Everything else is still there, so that subtraction symbol just drops. In a parentheses, we have x, which is -2 in its own parenthesis, plus y in its own parenthesis is 4, minus absolute value of negative, coming from here, and then x just so happens to be a negative value 2. Close the absolute value, close the parentheses. So again, first step, just dumping the numbers in, keep everything else around there just as it is. Now, a lot of things are going on here. And again, you have to really work with the innermost grouping and then work your way out. So as a result, this is seen as kind of that innermost grouping within that grouping. Now, ultimately, in that grouping, you end up with a -1 times a -2. That's an operation going on there. And so -1 times -2 is a +2, and you still have your absolute value. So we just did the operation within that grouping. Everything else, just for the sake of not mixing up negatives, we're just going to rewrite. And I know you might be thinking, but this is a lot of rewriting. Yes, you're right. You would be correct in that statement. However, as you progress in high school, honors algebra 2, pre-calc, AP calc one day, you're going to have a lot of just different steps. And if you try to combine steps, generally you're going to miss something, like a negative is going to pop up where it shouldn't. So that's why it's so important to show each individual step. Now we end up with absolute value of 2 is 2. That negative, we're just dropping. Again, most of the time, we're just dropping a lot of things, just rewriting, showing our work step for step. Now we end up with this innermost grouping. So all of these are still in a grouping, and we're going to go ahead and combine like terms. So -2 plus 4, well, that would be 2. And then inside of that grouping, you're still doing some more. So looks like a 2 minus 2 or 2 plus -2. That would be 0. And then -2 plus -0, or -2 minus 0 is still -2 in the end. And you may have ended up with the same exact results, but you're going to thank your future self if you show step by step, one at a time. Believe me, guys. I remember my honors pre-calc guys seeing it and being like, yeah, I forgot that negative because I tried to do 2 steps in one or 3 steps in one. And then on a quiz or test, they would miss something. So, guys, please, really, my hope is just getting those good habits in early so that you're just so used to it that it's pretty much second nature for you. All right. Um, Again, keep doing a fantastic job showing your work. So far, you guys have done an excellent job with that. So keep that up. All right, guys, have a blessed rest of your day. And again, that is our 0.4 notes. If you have any questions on 17 through 20, go ahead and rewind the video, see what part you may have missed. But again, that work part is so crucial, and especially creating those good habits for high school and college one day. But just as a quick reminder, these exploratory, hey, when are we actually going to use this stuff? This one, example 2, like example 1 and 2 kind of blend into each other, but example 2 is a fantastic one. Really take a moment, try it, because one day you will see a situation kind of similar to this. It'll be a little bit more indirect. You might not necessarily do the math behind it, but if you know your math, and especially if you're planning like longer term trips, it can benefit you. All right. So go ahead, try those. And yeah, we'll talk about those tomorrow. Have a blessed one, guys. Bye bye.